Hi class, I've gotten a few questions today about showing the examples that weren't shown in the original video for 9.2. So I am going to go through those in this video. So starting with number 2, I do want to show you how to do that, but as the original video said, I really hope you attempted it on your own because it is important that you're trying these and then checking your answers. So if you haven't tried example 2 yet, go ahead and try it now, pause the video, and then check your work. Okay, so solving by substitution. I noticed that the first equation has a y that's kind of lonely, so I choose to solve that one. It doesn't really matter what you choose to solve, whether it be which equation or which variable you're solving for, but just make your job as easy as possible. So I chose this one because, again, to get the y by itself, all I have to do is subtract 6x from both sides. So I get y equals negative 6x plus 3. So the step 1 of substitution is to make sure that you isolate a variable. Step 2 then is to take the other equation. So I'm going to take 2x plus 4y equals negative 10 and do the actual substitution. So I'm going to replace the y with negative 6x plus 3. So I have 2x plus 4. Now make sure when you substitute you use a parenthesis. Negative 6x plus 3, and it needs to equal negative 10. And now step 3 is to solve for the variable that's left. So in this case, I'm going to solve for x. Order of operations, first I need to deal with my parentheses. So I need to make sure I distribute the 4 to both the negative 6 and the 3. Combine like terms. 2x minus 24x is negative 22x. Plus 12 equals negative 10, and now I get the x by itself. So I subtract 12 from both sides. Negative 22x equals negative 22, divide by negative 22. So I should get x equals positive 1. Once I have that, I'm going to substitute it back into either equation. Now for me personally, I always do this step with the top equation, because ultimately I'm going to use both. So I plug back into the top equation. So 6 times 1 plus y equals 3. 6 times 1 is 6 plus y equals 3. And now subtract 6. So I believe my x is 1 and my y is negative 3. But my final step is to check. So I check that ordered pair back into the other equation. So I said in this step right here, I always use the top equation. So in my final step of checking, I use the bottom equation. And so I think x should be 1 and 4 should be negative 3. And if it in fact is, then when I simplify the left side, I should get negative 10. So I get 2 minus 12, which is negative 10. So it checks out. My last step is then to write my answer as an ordered pair, 1 comma negative 3 on the solution line. Okay, the next example that was not done in the video was the backside, number 4. So again, I look at the two equations and I pick the one that's easiest to solve for, and I see the top equation has an x by itself. So I choose the top equation, x minus 9y equals 11. I add 9y to both sides. I get x equals 9y plus 11. Then I take the second equation in this case, negative 3x plus 27y equals 5. And I'm substituting for x. So I got one question of, can I solve for either variable? And absolutely. Again, make your job the easiest. So I have negative 3. The x becomes 9y plus 11 in parentheses plus 27y equals 5. Distribute, I get negative 27y. Distribute, minus 33 plus 27y equals 5. Now let's see what happens. I combine like terms. I have a negative 27y and a positive 27y. Those cancel out. And I am left with negative 33 equals 5. Now in example 3, Ms. Galt showed you how sometimes when you do step 2 of substitution, the variables go away, but in example 3 you got 10 equals 10. And if I see 10 equals 10, I would say, of course, Ms. Selinsky, that makes total sense. So that was the situation when the variables go away and you get a number equal to itself, that you'd say it's infinite solutions on a line, or all points on a line. Having said that, in this example, all of my variables went away again, so I can't get an answer. But the problem is I get negative 33 equals 5. And I'm hopefully thinking that you're saying that makes no sense, Ms. Selinsky. And that is true. It doesn't make sense, which means there's no solutions. And when there's no solutions, you are done. Again, it's a false statement. It has no variables left. So if you get through step 2 after your substitution and all the variables cancel out and it's not equal to each other, that's when it's no solutions. Example 5. In this case, both equations would be fairly similar to solve for, except in the second one, the y is negative. So I'm going to use the first equation and solve for the y. So I'm going to subtract 2x. So I get y equals negative 2x plus 15. That's step 1. Step 2, remember, take the other equation, 3x minus negative 2x plus 15. Now be very careful on this one. The common mistake is people would not put the negative 2x plus 15 in parentheses, and they would forget to distribute the negative. So it should be 3x minus a negative is plus 2x minus 15 equals 20. So you do have to distribute that negative sign through. If you need to, you could put a negative 1 there. Combine like terms, I get 5x minus 15 equals 20. Add 15. 5x equals 35, divide by 5. I get x equals 7. Plug it back into one of the equations. Again, I always choose the top one just for consistency. 2 times 7 plus y should equal 15. 14 plus y should equal 15. Subtract 14. So I get y equals 1, which means I take the second equation, 3x minus y should equal 20 if I substitute 7 for x and 1 for y. And when I simplify that left side, I get 21 minus 1, which is 20. So that ordered pair does in fact work. So I write my final answer 7, 1. Last but not least, example 6 says solve by substitution, then check your solution on a graph. So graphing by hand. So again, this time I actually noticed that the second equation has the easier thing to solve for. So I subtract 2x. I get y equals negative 2x plus 4. Plug that back into either equation, or to the other equation, sorry. So I have to plug that back into the top equation this time. And that's my y value. So 2x minus 3 times negative 2x plus 4 equals 12. 2x, again, when we have a negative here, that's the most common mistake. Negative times a negative is plus 6x, and a minus 12 equals 12. Combine these, I get 8x minus 12 equals 12. Add 12. 8x equals 24. And divide by 8. So I believe x equals 3. I'm going to come down here for step 3. Again, I can take either equation. I'm going to take the top one as usual. 2x minus 3y should equal 12. X is 3. So 2 times 3 minus 3y needs to equal 12. 6 minus 3y needs to equal 12. Subtract 6. Bring down the negative. 3y equals 6. Divide by negative 3. I believe y equals negative 2. And last but not least, I'll do my final check over here. I take my other equation, so the second one, 2x plus y should equal 4. 2 times 3 plus negative 2, I get 6 minus 2, which is in fact 4. So my final answer is 3, negative 2. Now this says graph to make sure that that solution makes sense by finding the x and the y-intercept. Remember your x-intercept, so if I take 2x minus 3y equals 12, we did this last chapter. If I plug in 0 for x, that means this part would vanish. I get negative 3y equals 12, so that's when it's negative 4. But then we'd find the 0 for the y, so if I plug in 0 for y, this part goes away, and so I get 2x equals 12, and that's when x equals 6. So for my top equation, I have the point 0, negative 4, and 6, 0. Okay, but then I need to take the other equation, 2x plus y equals 4. Again, if I plug 0 in for x, this goes away. I get y equals 4. And if I plug 0 in for y, that means this part goes away. I get when does 2x equal 4? Well, when x equals 2. So this has a point at 0, 4. and 2, 0. Okay, and if we graph that line, again, it's a little nicer when it's in slope-intercept form because you're counting rise over run, but it does in fact look like these cross at 3, -2. Sorry, 3, -2, which matched my original answer. Okay, that's the rest of the examples. Make sure you go back and work on your homework and let me know what questions you have. Thanks.